Well, the snow lines are particularly interesting because snow lines are where we have ices. Ices are sticky. Everybody's made a snowball at some point in their life and found that when you push stuff together, it sticks. And so ices are an excellent way to start a planet growing. Well, a snow line on a mountain occurs where the temperature, as you go up in the atmosphere, gets cold enough so that water vapor freezes out into snow. And so the snow line in a protoplanetary disk is pretty similar. The snow line occurs where the temperature in the disk drops low enough so that a particular molecule, water in the case of the mountains, but there may be other molecules that do this in the case of protoplanetary disks, where they freeze out and become ices. In the protoplanetary disks, the temperature drops as you get further from the star, but then there's also vertical structure in the disk, and the vertical structure is such that it's coldest in the midplane and warmer as you get up higher out of the plane, because in the center there's a lot of dust protecting the disk from the starlight and keeping it cold. And so you tend to find the snow lines in that central disk at the point where the temperature drops to the level at which a particular molecule freezes out. Where the temperature is cold, there's not much energy, and there isn't much energy, it's hard to make a molecule emit brightly enough so that you can see it. Furthermore, the region over which the protoplanetary disk is cold is very small. Close to the star it's warmer, but as soon as you go out a little ways from that star, the temperature drops, and so the region where the snow line occurs is quite close to the central star. Stars grow out of these disks as material from the disk rains down on the central star. So it's pulled in by gravity. It's held up by centrifugal force, by the spinning of the disk. The material is coming into the central star, but it doesn't come in all in one steady stream. Sometimes the star can have a big lunch, a big blob will fall into it. Maybe one of those planets will fall into it. And when a big amount of mass falls into it, then it erupts, and then extra energy makes the snow line then move further out into the disk. And so the water snow line, instead of being very close to the star, is then further out. And so this particular star in Orion, where the snow line was discovered, is known to be what we call a flare star. Every once in a while it erupts, presumably because some of the material of the disk is falling into it. And so we think that's why the water snow line is visible in this one. It's further out because the star recently had an increase in its energy, and so it heated up the central part of the disk and drove the water snow line further out. So ALMA has both the sensitivity to detect the weak signals, and it has the resolution to be able to take pictures of the snow line at very high resolution.